All right, so we'll do another quick video here. This time we're going to talk, instead of central angles, we're going to talk about inscribed angles. So here's your central angle where 60 degrees corresponds directly with 60 degrees. The vertex is the center. Well, with an inscribed angle, the vertex is somewhere on the circumference, and then it opens up and it will intercept an arc. Okay, so we call this an intercepted arc if it's created from an inscribed angle. That IN prefix there being super important to telling that these are related to each other. Inscribed angle, intercepted arc. The theorem is that the angle is actually only half the size of the arc, or you can think of it as you would need to double the size of the angle in order to get the arc. It kind of makes sense, right? Because I'm not coming from this center point, right? Because I'm back here, I have more room for my angle to really open up. So it makes sense. We're going to have a larger arc here. So it's like, even if you have a 50-degree inscribed angle, if that were a central angle, it would just be a 50-degree arc, but here would be a 100-degree arc. So this leads to some interesting things, right? Here's the example I'm talking about, 50-degree, it's inscribed, so I would double it, and arc QT would be 100. Then here, RS is 48, which means angle T is 24, right? It's only half the size of that arc. So this is where things start getting interesting. And that's the idea of, if you've got two inscribed angles in the same circle, and the angles are congruent, then that means the arcs are congruent. And in fact, you go, well, wait a second. C opens up to A and B, and D opens up to A and B. Not only are the arcs congruent, it's the same arc. So if you are two inscribed angles that open up to the same arc, you're going to wind up having to be the same angle. So here we can start seeing some examples. So if this is 90 degrees, then that makes angle D 45. Right? If this is 38 degrees, then I would double that to get 76 for that arc TV. If this is 72, well, then the other angle is 72 because they both open up to arc ZW. This stuff is just fun and interesting to talk about. So if you inscribe a shape inside of a circle, so if you inscribe a triangle, if you inscribe a quadrilateral, then you say the circle is circumscribed, think circumference, meaning it's wrapping around the shape, and then the shapes are inscribed, meaning that their angles, the vertices, are inscribed on the circle. If you have a right triangle being fit inside of a circle, it would make sense that because there's a 90-degree inscribed angle, that means it opens up to something twice the size of that, 180 degrees. And so if this arc is 180, doesn't that make it a semicircle? Which wouldn't that make A to C the diameter, because that's what creates two semicircles, is the diameter, which means, wow, if you do a right angle inside of a circle, the hypotenuse is guaranteed to be the diameter, which I find just beautiful. And then the last piece here is that if you're going to put a four-sided shape in there, the opposite angles need to add up to 180 because, right, this arc, which I'll do in green, comes from angle D, and then angle F here opens up and creates this arc. So the green and the purple arc need to add up to 360, which means the red angle and the blue angle need to add up to 180. So we got some practice problems in here. It's good to pause and take a look at these. So you have to understand that Y and 68 need to add up to 180 because BD and BD this way. So the minor and the major arc, right, that are created there need to add up to 360. So there you go. We've talked about central angles. Now you've learned about inscribed angles. We are almost done here. Hope this video is helpful.